Okay, class, let's start where we left off. We left off on this last slide looking at subfields of psychology. We talked about basic and applied research, and we highlighted several professional areas of psychology. This is counseling psychology, clinical psychologists, psychiatrists, and community psychologists. The next area that we want to focus on when it comes to psychology looks at the need for psychological science. We talked about critical thinking previously. Well, there are some natural roadblocks to critical thinking, things that prevent us from thinking critically about information that's been presented to us. One of these such issues is hindsight bias. I knew it all along phenomena. Hindsight, as they say, is 2020. Something has already occurred. You already know the outcome of it. And then you sort of change your memory of what you knew at the time this incident was going on. And the idea is that we tend to be biased, meaning that we knew it was going to turn out that way. We then also have overconfidence. Humans tend to think we know more than we actually do. How long will it take you to complete such an assignment? You say 50 minutes. I should be done then. But in actuality, you are being overconfident. It may be more like 2.5 to 3 hours. And we also have this other issue too, perceiving patterns and random events. We can see a random sequence. A random sequence is unsettling to us. We don't like it. So we try to make sense of it. By making sense and seeing some sort of pattern in it, we tend to get more calm. So, scientific inquiry can help us sift reality from overestimated intuition and delusion. So, we have these tendencies that cause us sometimes to be inaccurate. And in order to be very good critical thinkers, we must know what our issues are, what types of biases that we may possess. So, just in sum, real quickly here, hindsight bias is the tendency to believe after learning an outcome that one would have foreseen it. Hindsight bias, overconfidence, and our tendency to perceive patterns in random events tempt us to overestimate our intuition, our gut feelings. So, psychological science and the post truth world. Why are we so vulnerable to believing things which are not true? We hear such terms bandied about all the time today: fake news, intentionally provided misinformation. And it does happen quite frequently. Oftentimes, those who say fake news all the time are most likely the ones who are perpetrating the event. Fake news is intentionally providing misinformation, sometimes referred to as spin doctoring or spinning the truth. We also have repetition. Repeated statements become more believable. Believe it or not, all that really has to happen for you to start to sway a bunch of people is to keep saying the same thing over and over and over again. And no matter how ridiculous it may seem, repetition does have an effect of starting to slowly sink into the individuals to start to believe that that statement that's being repeated over and over again is actually more believable. The other thing that we have too that makes us invulnerable to the untruths is availability of powerful examples. Vivid images and stories gain more attention. So the more vivid image that something draws up in your mind, the more easily that you can recall that, the more easily that we'll start to believe it. Vivid images and stories gain more attention. So when we are able to say, well, the last time something like that happened, you're able to recall it very easily, then you tend to believe it. So when we have examples in our mind and they're more easily available, we tend to believe those things which are more easily available to us. And oftentimes, vivid images gain more attention than not. Then we have group identity and the echo chamber. Basically, group identity and the echo chamber of the like minded. Groups and news that affirm our views, so they already agree with us, are accepted. News sources that do not are demonized. With this, it comes down to this. When we see something in the news and it agrees with us, agrees with our current held beliefs, well, that affirms us. We will accept that as the truth. We see some news that goes against our current beliefs, we will not accept it. So basically, what it comes down to, we're more likely to believe the things that, it makes really weird sense here, but we're more likely to believe the things when we already believe in them. So what this comes down to is the following thing that we have seen in our society for a long time now. This next slide talks about it. Psychological science in the post-truth world. What we're seeing here on social media, most people discuss contentious issues that are very controversial, such as gun control, same-sex marriage, or climate change, on with fellow group members. And on Twitter analysis, people overwhelmingly send messages to and retweeted messages from people who share their liberal, blue, or conservative, red ideology. So basically what it comes down to is this. When we go to the internet and we go to our favorite news site, let's say we tend to be more conservative, we'll go to conservative sites. And when we are posting messages to people on those sites, we're posting messages to people who are already very conservative like we are. If we go to the web and we're going to more liberal sites because we tend to be more liberal or progressive, we post to those sites, we're posting to people who also tend to be more liberal or more progressive. So basically what happens is, and we'll talk more about this in a future chapter, is that we become more and more polarized. We become more and more extreme in our ideas. People who are conservative and they go to these conservative sites, they become more conservative. People who are liberal and they go to these liberal sites, they become even more liberal. So this tells us the truth may lie somewhere in the middle, but we're more susceptible because we have this bias already built into us, and we're already going to be more accepting of things, as we stated earlier, that already agree with our held beliefs. So that gives us why we are susceptible to these untruths. Now let's talk about why psychology is a science. What makes it a science? Let's talk about the scientific method. Psychologists support scientific attitudes with the scientific method. So that idea that we talked about previously when it comes to attitudes, we have curiosity, we have skepticism, we have humility. Along with that, we utilize these scientific methodologies as well. Some key terms you should be familiar with. We have theory, an explanation using an integrated set of principles that organizes observations and predicts behaviors or events. So we have something that ties together some of our observations and allows us, if that theory is true, to be able to predict what's going to happen in the future. Hypothesis, a testable prediction often implied by a theory. So we have a theory, and this theory can help us to produce an hypothesis, a prediction based on that theory that we can then later test. Then we have operational definition, a carefully worded statement of the exact procedures or operations used in a research study. It tells us how we're going to make something that may be somewhat conceptual more objective, more concrete. We'll talk about some examples of that a little bit later. Then we have the idea of replication. Repeating the essence of a research study, usually with different participants and different situations to see whether the basic finding can be reproduced. One key aspect of research is this. We have a bunch of researchers and one of them does a study and they have certain findings. Part of the checks and balances of science is replication. Someone else reads their study and says, that's interesting. I wonder if I do this study with my population here, will I get the same results? They then conduct that same study with a different population of individuals. If they find the same results that were found in the original study, there's support for that particular theory and whatever that study was researching. If they don't find the same results, then that causes them to question maybe they did something wrong, or maybe the first study was not correct at all. But also, when it comes to checks and balances, it's unfortunate, but sometimes it happens where somebody may fake a study. They say this study happened and this is the results. Maybe they fudged the data. But when somebody comes after them and replicates the study and finds that no, this is not what we found at all, then it may cause people to realize that that first study, there may be some issues with it. The other topic we want to talk about is meta-analysis. That's a statistical procedure for analyzing the results of multiple studies to reach an overall conclusion. So let's say we have 100 studies on a particular topic. And when we look at the studies individually, we don't seem to find support for the theory. But then someone comes up and says, I want to look at all of these studies together. And then what they do is they go about performing what we call a meta-analysis. They look at all the studies and then, using meta-analysis techniques, combines them into one big study. Then they may be able to see some results that were being elusive to the 100 researchers, but together, looking at all the studies, they're able to find a significant impact. Then we have the case study, a descriptive technique in which one individual or group is studied in depth in the hope of revealing universal principles. We also have naturalistic observation, another descriptive technique of observing and recording behavior in naturally occurring situations without trying to manipulate or control the situation. And finally, we have a survey, which I'm sure everybody is familiar with. A descriptive technique for obtaining the self-reported attitudes or behaviors of a particular group, usually by questioning a representative random sample of the group. So when somebody calls you up for a telephone survey, that's what that represents. Or someone asks you to complete a survey for school or for work, that's what they're trying to get. They're obtaining self-reports of your attitudes or behaviors of that particular group to which you're a part of in order to get some idea to describe that particular population in some way. Now, let's talk a little bit more about some of these. First, theories. Theories are important. Many things stem from theories. Theories help us to organize our observations. They help to give order to disorder. So we have a theory about something and we organize all the observations that we've seen into these principles. Useful theories organize observations. They also imply predictions that anyone can use to check the theory or to derive practical applications. They may also stimulate further research that leads to a revised theory that better organizes and predicts observations. Let me give you a real quick example here. If you see a bunch of kids playing on the playground of different ages, and one group of young kids see another group of older kids get into a fight, a little tussle. And then later, you're still sitting on the park bench. Later, you see some of the younger kids sort of mimic the behavior they saw the older kids doing. Your rough theory there could be basically monkey see, monkey do in a way. Or you could say something like, okay, those younger kids learned those behaviors of the older kids, and now they're mimicking those behaviors. That is going to be the premise of social learning theory, which we'll talk a little bit more about in this chapter and in future chapters as well. But the theory helps to tell us what we are seeing with regard to our observations. They also can tell us what we may be able to predict will happen in the future. So let's say you're there on another day and you see some kids do a certain acrobatic move. The older kids do it. And you see some younger kids where we're observing them. You can say, well, I can imagine that one of the younger kids real shortly is going to try to do that same acrobatic move. That would be a prediction based on the rough theory that you have established as you're sitting there on the park bench. Now, let's look a little bit more precisely at a theory that could be done here. So what we see here is the scientific method, the relationship between theories, hypotheses, and research. At the very top, we have a theory that says something like this. Sleep boosts our memory. So if you get sleep, your memory is improved. So if we hold to that particular theory, this can lead to the following type of hypotheses. The example would be, when sleep deprived, people remember less from the day before. So if our theory says sleep helps to boost our memory, our educated guess, our hypothesis giving certain facts, let's say if that theory is true, if someone does not get sufficient sleep, they're going to be able to remember less than someone who did. So we have the theory, we have an hypothesis, and then that leads us to a research study. Here, we're going to give study material to people before an ample night's sleep or a shortened night's sleep, then test their memory. So imagine, if you would, you're at a summer camp. They give a bunch of material to two groups of students to learn material for that day. Then later that evening, when they're going to sleep, every time one group of students starts to go into a deep sleep or go into dream sleep, they get wakened up. So we interrupt their sleep. Whereas the other group of students, we allow them to sleep continuously through the night. The next day, we give them a test of the material they learned the day before. When we get the results from those tests, we can see whether or not the group that had their sleep interrupted performed less well than the group that slept throughout the whole night. If we get a confirmation, meaning that the group that had their sleep interrupted, they remembered less information than the other group, then that tends to confirm our theory. If the opposite happens, meaning the group that got very little sleep, which is most unlikely, but the group that got very little sleep, they recalled more information, that would tend to reject our theory. But let's say it's not clear what happened, that we did not see a real big difference between those two groups. That may cause us to have to revise our theory. So what it comes down to, we have a theory, which leads to a suggested hypothesis, which leads to a way to test that hypothesis. We get the results back from that test, and we can either confirm our theory, reject our theory, or it may lead us to revise our theory. So let's look a little bit more deeply at some types of methodologies when it comes to the scientific method. First, we have description in psychology. We can test our hypotheses and refine our theories by using descriptive methods, which describe behaviors often through case studies, surveys, or naturalistic observations. Correlational methods, which associate different factors, and experimental methods, which manipulate factors to discover their effects, are other types of techniques that can be employed. But let's look at the simplest ones first. We have the case study. Well, in a case study, we're simply describing in rather detail a small group or an individual. It leads to suggest fruitful ideas for future research, but we cannot generalize the results that we learn from these case studies to the larger population. Let me give you a crazy example. Let's say we're on campus, a big campus, and we have a basketball player who's leaving late class and walking home in the evening, and then all of a sudden it's dark and a a light from the sky above him flashes down on him. There's a space saucer up there, a UFO, and they beam him aboard their ship. And then what happens, as aliens do, they start to run tests on this young person. They learn everything they can about the human species in their mind. Then they release him, put him down, he doesn't remember anything, and they fly off to some distant galaxy to give their report to their masters. They get to their alien homeworld and they tell them that they've learned everything they need to know about humans because they were able to find one human, take them up into their spaceship, and do all sorts of studies on them. And they give a report like this: most humans stand about 6 feet 6 inches tall. They weigh about 220 pounds. They are very muscular. Now, think about that. They got someone who's a basketball player, who's an athlete. That person does not represent the larger population of the world. That crazy example I just gave you tells you one thing. When you have a case study, you may find some great information from that case study, but you do not generalize results to the larger population. You can't say that everyone looks like this athlete. With naturalist observation often involves new technology. For example, we see a lot of technology happening right now called a movement called big data. Anytime you go to a grocery store and you have one of those membership cards, they know what you're buying, they know your purchasing behavior and all this type of stuff. But the idea here with naturalistic observation is that it does not control all factors. You're simply observing people behave in their natural environment. It describes and sometimes illuminates, but it does not explain behavior. For example, you may know this from your own personal experience. Let's say you go to the Walmart parking lot and you're just sitting and watching people come from the store to the parking lot and all this type of stuff. And you see the following scenario take place. A bunch of people with their bags get into a car and they're piling in, and they see that someone is waiting for their prime parking spot. Do you tend to see people wait longer or take longer to get out of that parking spot if they know somebody's waiting for their particular parking spot? Well, that does seem to be true when it comes to the research that has been done. So that study could be done through naturalistic observation. It doesn't necessarily explain why they're behaving this way, but we do collect data that helps to describe the scenario. So we know that when you see somebody waiting for your parking place, that you're about ready to leave, you may tend to slow up a little bit, taking longer to remove yourself from that parking space. Now, when it comes to big data, this is something that we sort of have to deal with. We saw it with Facebook not too long ago, Twitter, Instagram. All these things are collecting data about all their members. Here, do big data make natural observation a big deal? Well, Twitter message moods by time and day. This illustrates how, without knowing anyone's identity, big data enable researchers to study human behavior on a massive scale. It's now is also possible to associate people's moods with, for example, their locations or with the weather, and to study the spread of ideas through social networks. So from this, you can see positive tweets were highest late Saturday night. Okay, so we know more positive words in tweets happen on Sundays. Okay, less so on some of the other days like Tuesdays and things of that nature. But the notion is that we can learn a lot about people by looking at how they're using their social media. That's the key point there. And we can develop profiles from this data that we collect about predicting what you're going to do in the future. Have you ever been on your phone, your smartphone, and then all of a sudden an advertisement pops up of something that you're actually interested in? Well, they have your profile. They've collected data on you for some time. And they sort of can start tying all this stuff together, and they can know and predict your behavior. Okay, so There are a variety of things out there that we'll continually talk about. We'll pick up on this when we get back, looking at the scientific method.